Welcome to our next video on exception handling and file handling in Python. We are going to cover both exception handling and file handling as per CBSE syllabus. As you might have seen, these are the first two chapters of your 12th uh, as per your prescribed syllabus. And out of your 70 marks theory paper, you see almost 12 to 15 marks covered across these two topics. So there are again 3 to 5 marks question where reading, writing in file, and then couple of objective 1 or 2 mark question describing certain concept or testing your basics around one of these topics, either about exception handling or file handling. So this is going to be again one of the very important topic for you if you want to score well in your exam. So far you have seen us covering your SQL syllabus in depth, followed by analysis and code level coverage for so far. I think we have covered 3 of your last 4-year paper, 22, 23, and one of the supplementary one, and we'll soon be having another video for your 2024 one. In this one also, exception handling and file handling, we will briefly touch upon some of the content as per your syllabus, and we'll try and have coverage that make us comfortable, and then we'll follow this up by review of actual question asked in your previous year question paper. So stay tuned. Let us deep dive first with exception handling. So when you write your code, right, all the time it might not execute as you expect it to, and there could be several reasons for that. So as you know, Python is not a compile type language, right? It is interpreted at the time of execution. So even if there are syntax error, then there is no mechanism that if you write that code and if you don't execute, there is no way of knowing many of those unnoticed error. So when you write your program that are having syntax errors, or the kind of input that you expect is not provided, those are another sources where your normal flow of execution or execution on your expected line will not happen. And from then there could be bunch of other typical scenarios where Python interpreter will throw error and a stack trace that you can use to sort of debug and see where the code is and where the erroneous code is and what are the issues. So here we'll actually try and understand, right, what kind of typical errors and exceptions could be there and how you can handle them effectively. So one major source, as you are saying, for erroneous execution is syntax error. So these are the errors that will be detected when code doesn't follow Python syntax rule. So on the right hand side, you can see in print hello, there is no closing parenthesis. So whenever this statement print hello without closing parenthesis will be executed, it will result into a syntax error. Exceptions, these are the errors that occurs during program execution. So syntax will be correct, but some of the uh, either certain values input as received from or as inputted by user, or certain intermediate computation might result into set of rule violation, right? So one that you see on right hand side is division by zero. So this will be the different than syntax error. These will be actually exceptions, and we will see that at runtime there could be a variety of scenarios where you don't have all the control, and so in those cases you would like to have proper control and a gracious exit from your execution. So these are actually important because in that case, as we said, they prevent abrupt program termination. Some of the common built-in exceptions are syntax error, the one that we saw, value error, when so for example, if you are looking for an input of type integer and you input their say float or string, right? So that's the value error. Then IO error will be there for when you try and open say a file that doesn't exist, and several variation thereof. Keyword interrupt, this will be there when when program is executing and you press some combination of control delete or other combination of keys that will actually uh, stop, so that will result into keyword interrupt exception error. And zero division error, we saw the example, right? Index error are another common source of error. So you have seen example for tuple. So say it is only having two object inside it. So if you actually say try and index third one, that will result into it. So but that's not a call from that's not. Let us review some of the others commonly seen built-in exception type. We have already covered syntax error and value error, as well as IO and keyword interrupt. Import error is when your requested module definition is not found. So these are the scenarios when we are trying to import a library and that doesn't exist. Then end of file error. So these will be raised when end of file condition is reached without reading any data by input. Zero division error, we saw some example. Index error, we just talked about it. Name error. So this is raised when a local or global variable name is not defined. So these are the error where you kind of use it before defining it. Indentation error, as you know, Python code block accepts code to be indented in certain fashion. For example, after definition of a function or another loop, right, there should be a tab or whatever you have defined, a kind of indentation, and code is expected to be there. So if there are indentation error, that will be covered here. Type error, right? So whenever there are actually mismatch in whenever you are having a mismatch or incorrect data type appropriate for that operator. And overflow error, these will be the scenarios where your intermediate calculation exceeds actually the limit set for that data type. These you might see typically in Fibonacci or your factorial if you actually try and compute for longer sequences. Now, how to handle it, right? So one thing that you can do is you can raise exception through keyword raise, right? So you may see the code below. If here, right, if age is if age is less than 0, then raise value error and then appropriate message, right? So if you want to explicitly range based on some condition, you can use keyword range. There are also more, commonly used a statement, particularly on uh, by users, right? So when you are writing some function, or when you are writing a piece of code where you expect arguments or certain intermediate value to be of certain kind or range, you can use the keyword assert, right? So assert, and then you can provide the expression or argument. For example, assert, and in this particular case, age is uh, greater than equal to 0. So if there is a 0 or less than 0, then this will result into error. Now, how to handle exception, right? So for handling exception, we use a combination of try, except, block, right? So you write your code inside a try and then semicolon, as you see on right hand side. Say for example, you are trying to get input enter number, right, through input. So you can put it and say you are assuming it to be integer, right? So you have actually kind of put a explicit integer conversion. So in this particular case, if someone doesn't enter value of type int, then automatically system will raise the value error, right? And there you can under the except part, you can actually take appropriate action. In try except, many a time when you are writing your code, you might have had some certain set of resources that might not be freed properly and might held on set of memory or other sources which could be prohibitive in one or the other way. So eventually when as you see, right, so except, and either you give a specific type or you can make it generic. So whenever you are whenever because of some reason, right, if it doesn't reach the accept also, then it will definitely reach something called finally, right? As you saw here, try, and then you can have one or more accept, and you can eventually have a finally. There is no so having finally with accept is not mandatory, but typically that's what that will follow. And inside finally, what you do, you'll actually try and release a set of resources that has to be done for proper release of those resources. So in this case, we opened a file, and the file object will be opened if you run into some erroneous scenario and doesn't close it. So finally, it's kind of in a place where you kind of clean up the mess, right, and release all the this temporary or other object stored. Now, how this process handling, occur, right? So you can, let's try and understand it through this flowchart. So an error encountered in a method, right? Say where you are actually divide by 0, right? What will happen there? System will automatically create an exception object at the very next thing, right? It will create an exception object, and then it will raise that exception. So the way you might have seen in previous example, say you are having this one, right, where if age is less than 0, raise value error, right? And say in this case that it was say supposed to be an int, right? So in that case, your value error will automatically be raised when it is not int, right? In a similar way. So for first, what it will do, it will actually create an value. It will create and exception object and then raise it. From there on, the runtime system searches for exception handler in the current method. So what will happen is you might have more than one exception handler, and it will go through them one by one, finding the most appropriate match, right? And if found, it will execute the code. If not found, it will forward the exception, right, where it can be handled at the next level, right? If it is found, it will be executed. Otherwise, it will terminate. So on the right hand side, if you see, right, say there is a numerator 50, denominator you are asking user to enter a value, and then you are computing quotient numerator by denominator, right? So if it happens, everything is proper, division performed successfully. Otherwise, what will happen? Say that your denominator that was entered was 0. So that exception will be handled by zero division error. So that's what this runtime system does. In the current, exception, in the current method, look for exception handler, right? And one that is found is zero division error. It could also be that user has not entered a integer value. So then it will actually be raising value error, and the handler that will catch is accept value error. So there you can take action that you want, right? So, and if nothing works, you can have an else block that can handle everything else. So this is also one possibility: try, accept, else, right? Another we talked about is finally. So all other exceptions will be handled in else part. Okay, so we are done with it. What we did, we actually introduced, exception. We also talked about that, um, you know, uh, what are the typical. We talked about syntax error. We talked about several built-in exception types. Then we looked at, how exceptions can be raised explicitly, and then what actually try, except, block does. And then we talked about a finally clause where you can clean up your mess and have a final chance before that execution goes out of current handling mechanism. Now this is what your CBSE syllabus recommends. Let's quickly go through some quiz on exception handling. So let's look at the one question, right? This is taken from your textbook. So every syntax error is an exception, but every exception can't be a syntax error. Justify the statement. True, right? So whenever there are syntax error, it will raise an exception of which exception it will raise? You saw here, right? It will raise syntax error, the first one, right? But every exception can't be a syntax error, correct? Because it could be an IO error, it could be an value error, right? It could be division by 0, it could be index error, lot of other things. Now the next question is built-in exception. So when are the following built-in exceptions raised? Import error, when to be raised? When a module that you are trying to import is not found. IO error, when there are issues related with a file opening, right? Name error, when there are issues getting that. What is the name error? You saw it here, right? What is the name error? When a local or global variable is accessed before assigned before access, or those kind of scenario. Zero division error, right? When you try and divide by zero. Let's look at another, fill in the blanks kind of approach. So on the right hand side, you can stop the video here, go through this code, and see if you can solve it. Yeah, I hope you are back. So say learning exception, try number 1, number 2. It's asking user to input and then explicitly casting it to int, and then it is doing computation of quotient is equal to num1 by num2, and then it is printing that both the numbers entered were correct. Then it's having an except block where it is printing a statement. Then another except block where it is saying that shouldn't be 0, and then a final else, and then finally it is having print job over, right? So what will be first fill in the blanks, except. So that will be your value error, because your error is not of your data entered is not of int type. The second one will be encountered when number 2 could be 0, right? So that will be denominator shouldn't be 0 and zero division error. And then finally block, right? The third fill in the blanks, where you can say that now job over and let us do something, or this is the place where you can clean up your mess and other things. Okay, so we had a brief overview on exception handling. Let's quickly move to file handling. And I think many of you 10 to 12 marks questions that are tested here, you will see a frequent 1 or 2 marks. So, and then you will see several questions where you are asked to kind of open a file, read it, and then take some action. So you have to actually kind of review your file handling related and practice past year questions. post this session, in the very next section we'll be actually reviewing your 22 and 23 paper, and we will look at all the questions asked on exception and file handling part. So what is a file? So far what you have been doing, the normal program that you write, say for example you write a code for factorial and you get the factorial for very large numbers, but then if you execute that program again or don't do anything else, the next execution again has to kind of compute all of that. Many a time in real world, right? Say for example you have actually in your code for your class you have generated rank by summing all the marks and following some other rule, right? Now once you have actually generated a rank and you have actually kind of got some grade finalized, right? Unless you store it, whenever you need to find grade or rank of a student, you have to do all of those execution again and again. And just assume, if you assume that there are say 10,000 students in your school and there is one system that does this computation, just imagine doing them on the fly every time a grade has to be looked up, right? So that process will become very, very tedious. So what you do is, once you do some important set of computation, you actually store that permanently somewhere, and that somewhere, one of that source is a very simple source for writing your information, and that you can retrieve later is file, right? So files, they store data permanently. This is the named location on the secondary storage like your disk, where data are permanently stored for later access, right? And they can be accessed through some kind of link that is associated with an identifier in your code block, right? So say for example you have say a file which is stored in your C program data rank, right? And there it is for a class wise, so class 8 dot say CSV, right? So you can always give that full path, and there are ways of opening and then start accessing it once you have actually kind of written it post your program execution, right? So that's what this file object is. It establishes a link between program and the data file stored in the permanent storage. So so that it is not lost forever. Type of files, right? So you see there are text files like .txt, .csv, or .py, the Python one that you do. Most of the time you'll be actually dealing with txt for writing your text kind of data, CSV for writing your comma separated data, Python for your normal Python code, right? And then there are binary files. So binary files are stored in terms of bytes, like zeros and ones for actual content, such as say emails, audios, or actually say compressed information of some kind, and they'll typically be having file extension of .bin. Let us look at some of the syntax. So opening and closing a file, right? So you use the identifier open, OPEN, and then you provide the file name, and then you provide an access mode. We'll soon see what access mode is, right? So access mode, basically when you are actually opening a file, you might be opening it an already created file to read it. So that's a access mode read. You might be opening it first time to write it, and you don't care if the file with same name exists. So that's the write for you. And many a time the file might be existing and you'll be appending at the end of it. So that's the append mode, right? And then there are several combination of it. So open will be your actually first thing, right? Once you are done, you'll actually close, and for close what you do actually also, say for example a file object is equal to open and then file name access mode. So to close it on the file object, right, you'll actually call the API, call the interface dot close. Okay. So after opening, right, you might see below, right, my object is open, my file.txt, And when you don't provide complete path, relative path will be taken, that will from your current working directory. And so you're writing it for W. So if the file exists, it will be actually all lost. A new file will be created with the same name, and the content will be all deleted, right? Then you have a multi-line things like hello everyone, writing this, this is something, right? And then you can actually yeah, just hold on. So we forgot introducing write and write ln. So once you have opened it, and if you want to write something, you can simply call write with string. So that is another thing, right? So all the write happens by converting it to buffer, right? And that actually string always, right? So file.write and then hello world, right? What happens if you have numeric one? That numeric one will get converted to its string version. Okay. So write can helps you write a bunch of things that will be as a single line in terms of one string at a time. If you want to write multiple lines together, that's why you have to use write lines, right? Write multiple strings from a list, right? So now you can see the example, right? My object is open my file.txt in write mode, then lines you have declared, line is holding 3 string, and then what you can do, pass this, my object.write line, the lines that you want, and then you can close it. Let us look at some of the mode that we are talking about. So read is one. Read is one which actually opens the file in read only mode, and there is a file offset. So where this will be a start. Whatever you do by default, they start at the beginning of the file. RB, so it will open the file in binary and read only mode, and this one will be again happening at the beginning of the file. R plus, so it both opens the file and both read and write. So difference between R plus and R is it only open for read, while R plus will open for both read and write. Plus R will also do the same. Write, if you do a write, it will open the file in write mode. If the file exists, contents are overwritten, otherwise a new file is created. And WB plus, it will open write in binary mode. A is for open, so file exists, and that's why it will start from the end of the file and start writing from there. A plus will be both for append and read mode both. You need to be aware of, because sometimes these are tested in your exam. Okay. Now let's look at file operations, which is reading from a file. So read, it will read the entire file from the file object. Say if the file we simply call file.read. Read line will read one line at a time, and read lines will read all lines into a list, and then you can iterate over it, right? So that's what it will see. The other things that are again very important and tested in your exam are for finding the file position. So tail, TELL, if you call on your file object, right? So file.tail or file object.tail, you'll get current position in file wherever it is. And seek you can use to move to a specific position, right? You might be worrying, you might be thinking why we need to be having some of these operators. The importance is, since you are doing some of these operation on disk, so many a time there are specific operators to kind of manage, because when you are doing things in memory, the access pattern was random, and here the access pattern by default is not random. Many of those behavior has to be get through a specific operations. So that's where seek is important. In seek, the which is SEEK, you provide an offset, which is by default offset and a reference point. So offset is nth byte, whatever you have, and then you have reference point. It could be 0, 1, or 2. By default, it is 0. 0 is beginning of the file, 1 is current position of the file, and 2 will be end of the file. So if you want to seek from where, say nth byte from end of the file, right? Seek nth byte from the current position or seek nth byte from the 0th position. That's why the interpretation of this will be sometime in your exam will be tested for the syntax around tail and seek. Another very important module that you have to be aware is called pickle, right? And as you know, when you are writing your code objects, so you have text, you have binary where you can write text, and binary you can write text, image, those kind of things. But when you are having a Python objects, right, many a time, if say you have a list, you have a dictionary, you have actually another data structure, and anything and everything, right, supported by Python. So what happens is many a time, uh, you need to store all your objects as it is, and then access them at a later stage, and then continue from there. So many of your machine learning related model, many a time when you have to kind of uh, all your computations saved and then restart from those saved computation. Pickle will be very important. So there are two important things: serialization. Serialization will convert a Python object to byte strings, right? So the way strings were converted to so other things were converted to string bytes. Here in serialization, Python objects are converted to string byte string first, and deserialization or unpickling, right, is where your byte string is converted back to Python object. So pickle, this is where serialization deserialization is, and you have two APIs for that: dump, which will write object to binary file, which means it will serialize, and load, which will read object from the binary file, which means it will deserialize. So to load the file, you only have to give your file data, while to dump it, you have to give a data and which file you want to write. Again, you have to be aware of this syntax. So we are done with the basic needed for file handling. Let's quickly go through your end of book page. Let's test yourself with some MCQ. What is the difference between text file and binary file, right? So text file store data in plain text. Binary file is stored in binary format. Text file are readable by human. Binary files requires specific program to read it, right? Text file is stored characters encoding. Binary file stored all of these are correct, right? You might have seen the difference between read line and read lines, right? So read line one line at a time, read lines multiple lines at a time. Use and syntax of method. Open, what will do for open? File name and mode. Read, only you give read and then size, right? How many bytes? Seek, offset and where, that the reference point that we're talking about, 0, 1, 2. And how you dump? Pickle.dump object and file, right? Comparison between a statement. Open practice R and P read 10, right? So what happens? Open will open the file and read the first 10 characters, versus with open practice.text R and x is equal to P of read 10. So here what happens is whenever you do with open, it will open and read as well as close the objects on its own, right? Cool. So we have come to the end of this module, exception and file handling. Just as a recap, we talked about we defined exception, and then we talked about typical built-in exception. We looked at the mechanism, how exceptions are raised and handled, and we talked about method of handling it through try, except, and finally structure block. Then we introduced why we need file. We talked about text and binary files. Then we introduced the typical APIs for opening a file, reading and writing, and through read write interface. And we also talked about multiple line read through write ln or read lines. And then we introduced looking at seek tail to get the current position, and seek to reach a certain offset. Then we introduced with, if you write with open, then actually that file pointer will be handled automatically. And Then we actually look at some of the modes which will be tested in your exam. Now, what we'll do is in the next subsequent video on this topic, we'll look at some of the interesting question. As you see, your exam focus is they are on practical side of the world, but they're expecting you to be hands-on and write code. So next one is going to be very, very interesting, where we look at last 2 or 3 years of your question paper, and we look at all the questions where they have asked you to write code for a specific problem around file handling and exception handling. This is going to be again very important, as I said during the beginning of this video. It will almost be of 10-12 marks, and out of 70, so big chunk, sometimes even 15 marks. So yeah, close to 15. There could be 2 5 marks, 4 marks, and another 3 marks, 2 marks. So typically 14 to 15 marks. So that's going to be significant. And they are again pretty, you can score very high. You just have to keep a couple of things in mind that we'll actually be teaching you in the next video. So thanks guys for tuning in. If you like the video, do subscribe my channel, like and comment, and see you next video. Thanks.